ꯉꯁꯤꯒꯤ ꯚꯤꯗꯤꯑꯣꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯑꯣꯞꯇꯤꯛꯁꯀꯤ ꯁꯦꯀꯦꯟ ꯄꯥꯔꯠ ꯑꯣꯏꯅ ꯋꯦꯕ ꯑꯣꯞꯇꯤꯛꯁ ꯑꯩꯈꯣꯏꯒꯤ ꯋꯦꯕ ꯑꯣꯞꯇꯤꯛꯁ ꯍꯥꯏꯕꯁꯤꯗ ꯂꯥꯛꯀꯗꯣꯏꯁꯦ ꯂꯥꯏꯠ ꯍꯥꯏꯕꯁꯦ ꯋꯦꯕꯅꯦ ꯍꯥꯏꯗꯣꯏꯕ ꯑꯩꯈꯣꯏꯅ ꯀ꯭ꯂꯥꯁ 10 ꯐꯥꯎꯗ ꯇꯝꯈ꯭ꯔꯤꯁꯤꯅ ꯂꯥꯏꯠ ꯍꯥꯏꯕꯁꯦ ꯔꯦꯅꯦ ꯍꯥꯏꯔꯒ ꯇꯝꯈꯤꯕꯅꯦꯕ ꯑꯗꯣ ꯁꯤꯗꯅ ꯑꯩꯈꯣꯏꯅ ꯂꯥꯏꯠ ꯍꯥꯏꯕꯁꯦ ꯋꯦꯕꯅꯦ ꯍꯥꯏꯔꯒ ꯀꯔꯤꯗꯒꯤ ꯂꯥꯏꯠ ꯍꯥꯏꯕꯁꯦ ꯋꯦꯕꯅꯦꯅ ꯇꯝꯃꯛꯏꯅꯣ ꯍꯧꯖꯤꯛ ꯍꯥꯏꯐꯦꯠꯇꯪ ꯈꯟꯅꯁꯤꯀꯣ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯑꯩꯈꯣꯏꯅ ꯑꯦꯛꯁꯄꯦꯔꯤꯃꯦꯟ ꯈꯔ ꯐꯪꯉꯦꯕ ꯑꯩꯈꯣꯏꯅ ꯁꯨꯃꯥꯏꯅ ꯌꯪꯁ ꯗꯕꯜ ꯁ꯭ꯂꯤꯠ ꯑꯦꯛꯁꯄꯦꯔꯤꯃꯦꯟ ꯃꯈꯥ ꯇꯥꯅ ꯇꯝꯃꯛꯀꯅꯤ ꯑꯩꯈꯣꯏꯅ ꯁꯨꯃꯥꯏꯅ ꯑꯩꯈꯣꯏꯅ ꯁ꯭ꯀ꯭ꯔꯤꯟ ꯑꯃ ꯍꯥꯏꯗꯤ ꯋꯥꯜ ꯑꯃ ꯂꯩꯔꯦ ꯐꯛꯂꯥꯡ ꯑꯃ ꯂꯩꯔꯦ ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯕꯜꯕ ꯑꯃ ꯊꯥꯜꯂꯦꯅ ꯈꯜꯂꯁꯤ ꯁꯤꯗ ꯊꯥꯜꯂꯤꯕ ꯕꯜꯕꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯈꯥꯔꯁꯦ ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯋꯥꯜ ꯑꯃꯃꯨꯛ ꯂꯩꯔꯦ 시기 마쿠나 마사리 후뚜에 시기 마쿠나 마사리 후뚜에 아들이 발랍시다기 라카드리브 라이트세 마디 시다가당 펑가동네 시다 마디 시다가당 펑가동네 아두부 시기 톡독시 톡대 방범 톡도바 마펌싱 아이 사이드수 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 수많이 펑네요. 요 망한 범징제 아생버기디 시기 아마지가 시기 마특시가 시기 마카지등가 펑가동네요. 아두부 마럭싱지다수 깔라가 그래서 망한이 ngan 탱나래요. 그래서 시다 아코나 까이 강에 light rays ray 오이나 트리 똑따라가디 light habse 시기 마펌 이 해본가 B 해본가 시가등 펑가동세 펑드래요. 아토포 펌싱지수 펑네요. 그래서 시 아코나 ray optics나 define 또본 감드래요. 수고모 페노멘은 그걸 탱나 아두더기디 그래 그는 웹 옵틱스 하지래 시제 그는 머루에 그나이도 탱나봐 거기 소록골라스타 그나 타오금 하이도가나 소록골라스 타오가 하이도가나 그나 레인보우 톡보기 타입다 마수지 우바 아들이 그냥 그 디터젠트 파우더지 마기 버블지 그는 피슈고 마tamdsu 버블지다 그들어봐 거기 레인보우 톡보다는 꼬친 젤을 우럭봐 sumber mayamsi kanana oilakpa masagi web optics habsin oilakpaneyo ni yengsi ko kana web optics habsi tamna bidong de kana lakena adidi koin mamang de so koin haigre web ama hairak taragadi kaino sumaina koina yan handa koina web amna haiba matam de consider toisi kaino koye isingne koina met urisi sumain isingi level ama leire si isingi level sida कोई नुंग में तारक पुम तंग सुमाइना नुंग में तारी सुमाइना नुंग में तारक पुम तंग के उतरी बसा माने नुंग में तारक पुम तंग दा सिगी इसिंग लेवल जे सुमाइना लेरम बदगी माजे के दरकनी साइ जगह जे कुथरकनी सुमाइना कुथरकनी अदुग माना कुथगी बे जगह सिदगी मुके दबा सि मु तोखलकनी थांगना बे जगह जे तोखलकनी माय हम जिंजिको मदम कुथरनी माय तोखलनी सुमाइना ने कोइना इसिंगी इपोम लेसि अदि सुमाइना लैजाबा इसिंगी पोमजे कमाइना तौरपा साइड लैबा वाटर की पार्टिकल से के तौरे सिना कुथरप साइबो साइड लैबा वाटर की पार्टिकल दुना तोंखतखि साइड लैबा दुना कुथरप साइड लैबा दुना मु तोंखतखि सुमाइ तौदुना साइड लैबा दुना कुथरप सि लैबा दुना तोंखतखि अदिदि सिगा चमानाना इसिंगी इमाइनेना खलजि सिगी बोर्ड से अदिदि साइजिदा तोंखलप मपासिंग फंगेना खलो तोंखलप मपासिंगजिना रेड ना दिनो तौरगे सिदा नुंगजिना साइड तारिनी नुंगजिना साइड तारिनी अदिदि साइ जगह सिदा के दौरे नुंगजिना सिदा ताबो मतमदा तोंखलप जगह am फंगे साइ मपादि तोंखलप जगह am फंगोइद्रा सुमाइना सब मानना तोंखलप जगह मयाम फंगे माने तोंखलप जगह am फंगे अदिदि तोंखलप जिगे हेक थांनाबदा मथंदा मुके दौरे कोइना अकुटप जगह सिंग मुंग फंगे सिदगी कोइना करी खंगे यमो अकुटप जगह सिंग जिने मयाम पुंजलकांदा सिगी सुमाइना कुथरी सिंग को अदगी सिगी अतोंग जगह सिंग जिने सिदा तोखली सिंग अदगी सुमाइ तौदना चाप मानना कुथमिनबा चाप मानम तोंखमिनबा मयाम पॉइंट मयाम से समझनर कांदा कोइना पुन्ना कुटलगा उरिने इसिंग इपोम से चेनबा मतम से अदि सुकुम माइना चाप मानबा matam amatada chamana ba displacement hadi ngasagi water level do chamana na tongkhan mineral pa ko sigi mafam ji demo sida nung je tabu matam da kedore sai jaga si chamana tongkhan mineral tra adugo loina na adi si 3D diagram na yekpati yatre ko hadi sida wire kadu sina ini ye sina 2D katane adi sigi mathak sida tongkhat pa adamai tok do sai de tongkhat pa sai de tongkhat pa mayam gi samjana ba adi natraga kuthaba mayam gi samjana ba sukum sing ji bokoina wavefront ko hadi samsan haraga wavefront haji kaine ba kogi chap manaba matamda chap manaba displacement cover tawminaba point mayam do adugi collection ji bokoina wavefront ko natabida atoppa amada si bokoina phase hai phase ati angle hai bane koina physics ta ko ana same angle cover tawminaba at the same time da si bokoina kai ko ba wavefront ko si collection of points wavefront to akhon ising jina taba matamda kedoba sumaya tongkhatpa mayam ama leire khala jisa atong musing do ko atong musing je leire khala si lena akut pasing mu leire se samana kuthaminaba natura samana tongkhanminaba sigi collection of points ji bokoina wavefront gawe ana wavefront gi makhal ahum lei number 1 da magi type se number 1 da magi spherical wavefront haiba ma spherical wavefront ji de koini sida phangi jemo sagi da leiba point am khakta ko ai animation video jo hapake ana side leiba point am khakta wave si hau taragadi ai light source oi taragadi kidawni mana circle am oi kani circle magi wavefront circle wen adi sisi ko si koini source ni sumai to na koina circle oi kani circle je koini 3 dimension la adi kana la sphere oi na phange aduna spherical wavefront phange kanana point source point source na koina kana phange ba spherical wavefront phange mithangda cylindrical wavefront jina kana piba line source ma khang sigi line source na oitaragadi kana pirani magi wavefront je cylinder oirani mana sina line source da mathangda plane wavefront is kanana piba spheric point source amadi point source or line source magi source point source amadi line source wai kamani yengsi koi prithvi sibu matum tai haire ado akhoi side di matum tabra ne ta de kari gino tabre ja akhoi gi size si gi yengno matam da prithvi si yamna chaw reba aduna yamna chaw gi distance amada di kedore eba madi plane oin urakane adu yong sigi akhoi gi sigi spherical wavefront je ti yengsi ko si sum chaw thoro adu si tin thorak trasa sum tin thore ko last side di kana hole ma se plane wavefront ole aduna point source na the line source at a very large distance then the lap kiba distance ta plane wavefront kana na puthoeba point source amadi line source na puthoe wave optics se Kanada base of magi foundation ji kana na pi ko karam theory na pi ge di Huygens Principle na ko Huygens Principle na malai bisna pi ge ni Huygens Principle man hai si kari no sumai tok dana ko ge web source ma lai re sigi web source na maram moiraga mana kana puthokani web source lai taragadi wavefront puthokani ha mai do na wavefront no puthore wavefront no puthore sigi wavefront web source na kana puthore ba wavefront no puthore puthore ba wavefront sigi every point khudimok se khona ne web source on treat to ba ya adai tarik ke do ne ma je sigi point ko web source on treat to ba ya di mana su wavefront puthom ne mana puthokade wavefront no bismai mana ohila ase puthore ba wavefront na ko na wavelet ko natraga secondary wavefront natraga wavelet ko amuka haige point number 1 da hari se kaino matamda source ama leitaragadi haige web source ama akoi light source ama leitaragadi mana wavefront puthorakani puthore ba wavefront na maram waraga kana puthore mana wavefront no puthore ba wavefront du koina wavelet ko re sina point number 1 ko are mu wavelet singi kedawa magi speed se wavelet singi speed of light ko si water the way speed of light in water the air the way speed of light in water vacuum the way speed of light in vacuum so mai tok dana wavelet ki speed se kedawa light ki speed adum sat kane mangon thengda hoba khota hoba karin ta leite ko aduna nasai wavelet singi tianjian ji the wavelet singi da khona tianjian ji yung side level point du di mas minus semoidra ko side level point du is minus semani sa side level du side level du su mai semani adudi wavelet singi gi sumaina tianjian exilak tar ge khona sumaina curve ma tar pra sumaina curve ma tar ko tianjian singi samjina ra ganda si curve sina kana pi ge matanda next ki wavefront bi si curve ma ande punjala kana pi ba next ki wavefront bi next ki wavefront adu next ki wavefront ji kana puto ko ile me ko yi wavelet na puto ko ile me sini ba ko Huygens Principle hai si ko Huygens Principle number 1 ka heba web source ama laitar ka di mana wavefront puthokani wavefront every point khudimak wavelet oina web source oina treat to bayai ade second point dum ka hare masagi treat to bayari ba ide web source oina treat to bayaramni mana su wavefront puthokani puthori du bokoina wavelet ka wi ade wavelet sing du gi tangent sing du na wavelet sing du ye ko tangent sing du na kana pi ba next ki wavefront pi.
A small pebble dropped in a pool of still water creates ripples on the surface. These ripples form concentric circular rings around the source of disturbance and spread outward along the surface. When these ripples reach a point on the surface of water, the point starts oscillating up and down. Different points, which are at the same distance from the source of the disturbance, oscillate in phase. That means all these points reach the crest or trough at the same time. The locus of all such points having the same phase of oscillation is called a wavefront. In case of water waves on the surface of water, we observe circular wavefronts. Each circular wavefront is a locus of all points having the same phase of oscillation. The propagation of the waves can be understood by studying the propagation of wavefronts. An outward normal drawn at any point on the wavefront represents the direction of the wave at that point. In terms of energy, we say that the energy of the wave propagates in a direction perpendicular to the wavefront. The speed at which a wavefront travels is the speed of the wave. Waves on the surface of water are two-dimensional, and hence the wavefronts are circular in shape. But the waves from a source of sound or a source of light in a homogeneous medium spread in all directions and are three-dimensional in nature. Now consider a point source of light placed in a homogeneous and isotropic medium, emitting light waves in different directions. If the medium is homogeneous, the speed of light waves is the same throughout the medium, and if it is isotropic, it is the same in all directions. The loci of all points, which have the same amplitude and vibrate in the same phase, forms a sphere with its center at the source of light. Hence, a spherical wave front is generated when a point light source is placed in a homogeneous medium. At a large distance from the source, these spherical wave fronts have large radii of curvatures. A small portion of a spherical wave front at a very large distance from the source can be treated as a plane wavefront. In physical optics, we visualize light as waves and wavefronts. In ray optics, we visualize light as rays. A line drawn perpendicular to the wavefront in the direction of its propagation is treated as the ray of light in ray optics. Note that a wavefront is a surface of constant phase. If a particular wavefront is a locus of points with maximum amplitude, it continues to be like that as it propagates through the medium. Christian Huygens proposed a geometrical method known as the Huygens Principle for finding the shape and location of a wavefront at some instant from the knowledge of the shape and location of the same wavefront at an earlier instance. According to Heightens Principle, each point of a wavefront is a source of a secondary disturbance and generates spherical secondary wavelets, which spread out in all directions with the speed of the wave in that medium. If a tangential surface common to all these secondary spherical wavefronts is drawn, then it gives the new position of the wavefront at a later instant. This surface envelopes all the secondary wavelets. To understand Huygens' principle, let us now consider a primary wave front AB propagating in a homogeneous medium. Then, according to the Huygens principle, each point of AB acts as a source of secondary disturbance. The secondary wavelets emanated from these points are spherical in shape and spread in all directions at a speed equal to the speed of the wave. If the speed of the wave is v, then in time t, the radius of the spherical wavelets becomes vt. The tangential surface common to all these spheres in the forward direction gives the shape and location of the new wavefront after t seconds. In the image, the surface A'(B' represents the location of the wavefront AB after t seconds. The secondary wavelets must be directed backward as well as forward from the secondary point sources. If this would be correct, we would get a surface such as A'(B') as a back wave. But experimental results do not show the presence of any such back wave. In order to explain this, Huygens proposed that the intensity of the spherical wavelets is not uniform in all directions, but is maximum in the forward direction and zero in the backward direction. Hence, the wavelets as well as the whole wave always propagate in the forward direction only. Now let us use Huygens' principle to find the location and shape of a plane wavefront at a later instant of time t. Let AB be a plane wavefront at time t equal to 0. According to Huygens' principle, each point of AB acts as a source of secondary wavelets, The radii of these spheres will be Vt after t seconds. The plane touching these small spheres in the forward direction gives the shape and location of the new wavefront after t seconds.
Laws of refraction. Refraction using Huygens Principle. Huygens Principle. Huygens Principle sizinarkanda akoina laws of refraction proof tokse. Sumai tawdana medium ani khak laire magi interface akoina sumaina plane interface ama laire an khalasi. Sigi plane interface da incident light ko plane wavefront umkak se sidadi akoina wavefront aina hairani sumanya plane wavefront umkak paisile plane wavefront umkak tarare kadaida plane wavefront sigi maming kana plane wavefront sigi maming A B ne thonsi sigi plane wavefront se interface da tarore sona kangi medium sina koina medium sida lai magi refractive index na n1 an thonsi sigi medium se light ki velocity sina koina b1 an thonsi sigi medium sida laiba light ki kedowa magi medium sigi refractive index na n2 na thonsi aduga magi velocity sina light ki velocity sina b2 na thonsi sida koina incident light de tara di akoi hongna bi kedorani normal yani normal yani ta normal among yani ko sina n1 haige sina n2 haige sina n3 haige sina n4 haige ko adidi light is after refraction ko sigi mafam sida ko sigi sina koina c thonge sina koina d thonge ko adidi sidi yengse light is mo sigi mafam sida plane wavefront kadai le ni sa ko sina d sina e na haige si akhoi kanano angle of incidence ni samana na si jungai ro angle of incidence ade light is na e dai na d bok chapa matam da travel tawriba time taken je kuna t na haise sumaina after refraction tor ko matung da light is kamai la sumaina normal on the bend of sele na khalas samana na si jungai ro normal on sumaina bend of sele ka doi sumaina bend of sele ko matung de ngo light is hanta mukti ko dawre magi plane wavefront ma ye ke hai taraga di sida perpendicular on tarani ko perpendicular on tarani the perpendicular on tarai se mo kone to sumaina to action bagi wani aseng bagi di sinate light is ke dawa time taken yongo e deina d bokta time taken je siga chamana na c deina c bok ko c dagina d e f na thunjin jisa ko c dagina f of ki time taken je mana doine sigi manaba matam sida khoina sida kedawa curve ma arc ma ye kadoi ko ade c deina f of da cover tawriba time se t hoidoi samana na kadai da e deina d bo aduri n1 ga n2 ji kana tensor oire khallo ko sina khogi angle of refraction this is our angle of refraction. Let A B amadi C E mujikana no A B and the C is incident plane wavefront incident plane wavefront aduga I sin kanano angle of incidence n1 sina kanano refractive index of the incident medium adagi b1 sina kanano velocity of light in the incident medium adagi df sina kanano refracted refracted plane wavefront. R sina kanano angle of refraction, N2 sina kanano refractive index of the refracted medium, B2 sina kanano velocity of light in the refracted medium. Si sing sini ko khoi na chang ja ri T sina kanano time taken of the light from in the ED and CF. Consider right triangle om lai re ko right angle si lai re right angle ma sisu right angle ni ko adu diang si in right triangles kana CDE and CDF right triangle ani si diang si C ki angle si di kana ka mani mo C ki angle si kana ka mani normal having is 90 degree. Adagi mo masana ko ge plane wavefront is magi propagation direction is the perpendicular oina do ni se. Adagi si angle je common oidra si angle je koina angle of incidence oisara ne ba masana. Le samana na sina ko ge angle of refraction oisara ne ba. Check to ko sa. Adagi yo sin of I je the perpendicular by hypotenuse. Matang is the perpendicular DE divided by hypotenuse D CD. Dariko adrigimo N sin R triangle CDF tamo kanagamanare perpendicular D CF divided by CD. CF divided by CD tar. Again, when ratio mo putuksi mo again sin I divided by sin R ji kya ta geng si ko adidi sin I ki value di DE by kana CD aduga sin R ki value na CF by CD adidi CD ga cancel sakre DE by CF le mo DE ji ka da DE mari kana no akoina displacement ne length ne ba samana na CF su length ne ba adidi length or displacement is the velocity into time na tro si ju velocity into time adidi kana no yengsi e dai na d bok chat pagi velocity di kana no v1 adidi si v1 hapi rani magi time di t ni t rim thambi re si dai na f bok chat pagi velocity di v2 ni adidi si v2 na thambi ra si adidi amuk time di t ni adidi t ga t cancel sat karo usi akoi ja thauri se v1 by v2. This is our sin I by sin R. Si mo phang ko da ali yung si sin I by sin R. Si kana ga manare. v1 by v2 de ko in terms of refractive index ta hari gadi n2 by n1 si di kana no n2 with respect to n1 natro si di Snell's law tadro sin I by sin R equal to refractive index of refracted medium with respect to incident medium. This is our laws of refraction je kanana Huygens Principle seasonal ko na prove tawo